All right, so we've got 28x cubed over 56x to the 7th. I need to know, Hallie, what number could I divide both that 28 and the 56 by? Okay, so 28 goes into both of those. Sometimes you might not recognize that a number that large will go into both of them. If you don't, you could just do the 7 that'll go into both of them, and then it's just going to reduce again. So 28 goes into both of them, which gives us 1 over 2. Then, Hallie, what am I going to have for my x's? Yes. Good. Perfect. So if you think about writing that out, you got 3 on top, but you got 7 on bottom, so 3 of those are going to cancel out. So 7 minus 3 gives you 4. You're going to put those on the bottom where you have more x's. Okay, so those two problems are things that we do in Math 1. Here is another, and really all of what we're doing today is Math 3 sort of stuff. We're not doing new stuff. Actually, honestly, I think this whole section is in Math 3. This whole section of this unit. I don't think you guys do inequalities. Now, once again, let me warn you of what students start doing. Don't write down what I'm about to do because it is bad. They say, oh, I see an x right here. I'm going to cancel it with that x right there. They might even say, oh, 2 and 6, that could be 1/3. This is bad. Do not do it. You cannot do that because you have plus and minus signs. This stuff is not multiplied together, right? We cannot cancel those, just like we could not, like if I had 2 plus 1 over 5 plus 1, right? That should be 3 over 6, which is 1/2. But if I apply that same bad logic to this, if I cancel this 1 and this 1 right here, which a little bit seems like you should be able to do that, then I get 2/5. Does that equal 1/2? No, it does not. So you cannot cancel when you have plus or minus signs in between. Every time you do it, it causes a math fairy to die somewhere. And there's been a lot of math fairies murdered by my students over the past 14 years by this very thing right here. So we want to keep the math fairies alive. So we're not going to cancel when there's plus or minus signs in between. We're going to try not to. Because for some years I've had entire colonies of math fairies just wiped out by the students. So we're going to try not to do it. So what we have to do for this is we've got to break it up so there is some multiplication. And so to do that, we're going to factor the denominator. The top won't factor. In this denominator, though, we can factor that. So Bronwyn, how will that one factor for us? 5 and 1 will give you the 6 on the end, but will it give you the 5 in the middle? Because if we put a 5 and a 1 here, then we'll get a 5x here, and then we'll get a 1x here, which will give us 6x in the middle. Because they have to add to give you the middle number. Actually, and this will be backwards anyway, because 5 times 1 will give you a 5. So that will be backwards from what we want. Almost. This. If I want students to miss a problem, I can give them x squared plus 5x plus 6 because of exactly what you just did there. So if I do plus 6 and a minus 1, now I've got 6x and I've got minus 1x. That looks great. That gives you 5x. But what's 6 times negative 1? Negative 6. I need it to give me a positive 6. Right there. So I can't use a positive and a negative on this. It's 2 and 3. This problem right here, if you had been a math teacher as long as I have, you would know that it causes great anguish for students because they either use a 6 and 1 when they shouldn't, or they use a 2 and 3 when they shouldn't. Some combinations of 5s and 6s right there is going to get students every time. So a plus 2 and a plus 3 there. So notice what I've got here. I've got multiplication between these two. I don't have multiplication up here, but could I write it like this? 1 times x plus 2. So these two things are multiplied, and these two things are multiplied, and highlighter. And this piece right here matches this piece exactly. Now there is a plus sign inside of those parentheses, but this entire unit, this entire factor here, is being multiplied by something else, right? So it is okay to cancel at this point because I don't have plus signs or minus signs in between the things that I'm canceling. It's inside, which is okay. So I could cancel these right here, and that's going to give me 1 over x plus 3. Now, we do have to put a condition on this. I should have said this from the beginning because our worksheet's going to ask us to do this. There are some numbers that we cannot plug into this because it's going to give us something that's undefined. Okay? What number could I not plug in to this? I could not use -2, and I cannot use -3. Because either one of those would give me a 0 in the original function. So before I cancel, if you wait until after you cancel, you're not going to have that plus 2 right there. So before you cancel anything, you want to say, hold on, what are my excluded values? What are the values this cannot be? So this is our answer as long as x does not equal -2 and x does not equal -3. Just the values that would give you 0 in that denominator. Okay, questions? All right, let's try this next one here. Alright, so we've got x squared plus 2x plus 1 over x squared plus 4x plus 6 times x plus 4 over -x minus 1. Remind me, how do I multiply fractions? Just straight across, right? So that's always something I try to really stress is operations with fractions here. So you don't have to have common denominators to multiply, you just multiply straight across. Now, I could multiply all of that stuff together, but that will make it worse rather than better. So I want to factor just like I did before. So x squared plus 2x plus 1. Grace, what's that going to factor into? Perfect. X plus 1 and x plus 1. Reese, what about the denominator? Perfect. And then I'm going to put these in parentheses also, x plus 4 and -x minus 1. Okay, so now if I look, everything here is multiplied. I'd multiply straight across, so this is really multiplied here, and then this is multiplied here. So I've got multiplication, so I can cancel factors. So my x plus 1s here can cancel. Can anything else cancel? Not as it is right now, but got this x plus 1 right here, and I have this -x minus 1 right here. Those seem pretty close, except for the signs are just wrong on this one, right? So, whenever you see that happening, when the signs are just backwards, right? Otherwise, they would cancel, but the signs are backwards. Here is something that you can do. So I still have this x plus 1 over x plus 3, and I've got my x plus 4. I can factor out a negative 1. So if I factor out a negative 1, that would give me x plus 1. And so this is still all multiplied, right? X plus 3 times negative 1 times x plus 1. So we can actually cancel those x plus 1s also. And it is going to give us x plus 4 over negative 1 times x plus 3. Or you might distribute that negative back out. Actually, what you're probably going to see is that negative, that negative 1, it could be in the top, it could be in the bottom, it could be out front. I think you'd probably actually see him put it out front and do x plus 4 over x plus 3. Or it could be distributed in where you got x plus 4 over negative x minus 3. But if I put this negative out here, it could go top, bottom, out front, any of those. I did not do my excluded values on this. So when we're looking at excluded values, we want to look at the denominator of the original, right? So for the denominator of the original, I would have x plus 3 cannot equal 0, which is going to give me just x cannot equal negative 3. I would need x plus 1 cannot equal 0, so x cannot equal negative 1. And then I'd have this negative x minus 1 cannot equal 0, which would give me negative x cannot equal 1, which if I divide, just gives me another x cannot equal negative 1. Ends up being the same there. So I would have, this is my answer, but x cannot equal negative 3, and x cannot equal negative 1. Okay, here. You always want to do those excluded values from the original problem right after you factor it. You don't want to wait till you get down to the simplified version because something probably canceled that would have given you a 0 in the original. And it looks like it disappeared, but it is actually still there. All right. Okay, here's our next one. So we have x plus 5 over x squared minus 3x minus 4 over x squared minus 2x plus 1 over x minus 4. And this is ugly. This is what we call a complex fraction. It's when you got fractions inside of fractions, and nobody wants to have double fractions, right? We already avoid fractions, most of us anyway. So, but it's okay because dividing fractions is easy as pie. Flip the second and multiply. So that's going to look like this. X plus 5 over, is it okay with you guys if we go ahead and factor this right here? Put it right there. Let's see. Hallie, how will we factor x squared minus 3x minus 4? Yep, x minus 4 and x plus 1. That looks perfect. And then I've got to flip the second and multiply. So I've got this x squared minus 2x plus 1 over x minus 4. I'm going to flip it so that x minus 4 is on the top. And then I'm going to need to factor this piece right here to put it on the bottom. And so, let's see, Noelle, how will that factor? not quite. If it was a -1 and a +1, it would cancel out for those middle terms. It has to be 1 and 1 to get that +1 on the end. You're going to make them both negative. So you'll have a -1x and a -1x, which will give you -2 when you put them together. All right, so I'm going to put this, although it's not necessary, I'm going to put these numerators in parentheses. Everything here is multiplied. And so we're going to see if there's anything that will cancel. This x minus 4 and this x minus 4 right here can cancel. But that's it that will cancel there. So we would just write x plus 5 over, they'd probably write it like this, x plus 1 times x minus 1 squared. So these are also a little bit tricky for your excluded values because anything that is in the denominator ever cannot be equal to 0. So that means that right here, that x minus 4, we will get x cannot equal 4. X plus 1 is going to give us x cannot equal -1. And then you got two x minus 1s here, but x cannot equal +1. And over here, in the very beginning, x minus 4 was in the denominator. So it actually has already been listed because it was a factor in both places. But x, you have to say x minus 4 cannot equal 0. That just gives you the 4 that we already have listed there. And questions? Yes? If it's there twice, if we were going to, so like, are you talking like one of them cancels and one does not, or?
No, it's like in math 3, in math 3, it's like if they both can't, if it can't be done twice, if one can't be done twice, then like then it's like it's like multiplicity of 2 or something.
Okay, I think you are thinking about whenever you're like graphing these functions, and so it's not really for rational, but if you have a multiplicity of 2, and I think what you're talking about, I think you're thinking about maybe like when you graph it, it's going to like just come down and touch the axis and then go back up, maybe. It affects what the graph will look like there. So you're probably thinking of the zeros whenever you were doing zeros for those problems, which we don't really have to worry about here too much because we won't be graphing them. We have already done rational equations a little bit. If I have something that cancels on top and bottom, and we're thinking about the graph, what does that cause on my graph? What does it look like on the graph? It's a hole in the graph, right? And then anything left in the denominator is going to give us a vertical asymptote. So this one would have a hole at x equals 4, and then it would have vertical asymptotes at x equals -1 and x equals +1. We did, no, we didn't do those out of order. So that might be something that shows up. All right, and I've got just one more I want us to do. And then I'm going to give you guys your assignment. Alright, so I've got 2x cubed plus 4x squared over x squared plus 2x times x squared plus 3x over 6x plus 10. So nothing will cancel as it is. I've got plus and minus signs here, so I can't just start marking x's out. How do I factor something like 2x cubed plus 4x squared? We can take out an x. And in this case, we can actually take out a 2 as well. And we can take 2 x's for that one because we've got x squared as our lowest. So we're going to do a greatest common factor there. A lot of times this throws students when they get to these problems because they've forgotten about those greatest common factors. So that would just leave us an x right here and a 2 for that second one. Whenever you're doing greatest common factors, it's like you're just dividing both terms by that greatest common factor there. So Blaine, what would it look like in the denominator there? Yep. This one won't factor into like 2 parentheses easily. We're just taking out that greatest common factor. What would that be? We can't take out the 2 because like here we have a 1 and it's not divisible by 2. So as far as the numbers go, 1, like we could take out the 2 up here because 2 and 4 were both divisible by 2. But here 1 and 2, other than 1, there's nothing we could divide both of those by. For our x's, we want to take out the lowest exponent, which in this case is just 1, right? So we're going to just take out an x. So it's like we're taking 1x away from each one of these. And so I had x squared, which was 2x's. I took 1 away. That just gives me x. You're thinking like you're just dividing that. So it just gets rid of one of those x's. And then over here, I had 1x. I took that x away, which is going to give me 2. So Blaine, the numerator is similar on this next one. How would we factor it? Perfect. And then what can we pull out of the denominator there? We can't take an x because that 10 doesn't have an x with it. What number could I divide both of those by? 2. So we could do 2, and then we'd have, what would be left on the inside the parentheses, Blaine? Good. All right, so now that I have everything factored, that means I've got multiplication here, multiplication here. In between these, I've got multiplication because to multiply fractions, we just multiply straight across. So everything's multiplied. I can't do something crazy like cancel the x's right here, but if I'm canceling entire factors, I can cancel those. So x plus 2's, they can be gone. I could cancel this x with this x right here. I could cancel this 2 with this 2 right here. And I think that is about it. So then we just multiply straight across whatever's left. So I'd have an x squared and x plus 3. Make sure you don't forget parentheses whenever you write that on the top. And on the bottom, all I've got left is a 3x plus 5. You can put parentheses, but since it's the only thing left, you don't have to. Okay. Nothing else will cancel because I can't cancel one of these x's with anything down here because I've got this plus sign in between. Not everything's multiplied. I did forget to do excluded values for this one. So again, excluded values, you want to think about it before you cancel. Anything that would give you a 0 in the denominator. So right here you had an x, so x cannot equal 0. X plus 2 cannot equal 0, which would be x cannot equal -2. Here your 2 cannot equal 0, but does 2 ever equal 0? No. So we don't really have to think about that. Then 3x plus 5 cannot equal 0. So basically just everything in that denominator cannot equal 0. If I move that 5 over, I'll have a negative 5. And if I divide by 3, x cannot equal negative 5/3. So excluded values for this would be x cannot equal 0, x cannot equal negative 2, and x cannot equal negative 5/3. Okay. Question? Yes.
Where did that cannot equal 0?
It was from this x right here that I marked out. So this was a factor right here, that x. So every piece has to be set not equal to 0. So that x right there could not be 0. Okay, questions? All right, so your assignment today is a worksheet that's